Problem number 1, what we want to do is we want to find a common denominator because we are going to be subtracting these two values. So the common denominator for 5 divided by y squared minus y divided by 2y minus 1 is going to be y squared, and 2y minus 1, 2y minus 1. So our common denominator now is y squared over 2y minus 1. In the numerator, we'll still need to multiply these out, but we have 5 times 2y minus 1 minus y times y squared. If we multiply these out, we end up with 10y minus 5 minus y cubed, all over that denominator, y squared, 2y minus 1. And what we'll want to do is we'll want to write this now in order. So we'll have this as minus y cubed plus 10y minus 5 divided by y squared, 2y minus 1. For problem number 2, what we want to do is again find the common denominator. In this case, the common denominator, what is missing is an x plus 5 here. So we'll multiply both top and bottom by x plus 5 and x plus 5. Why that is missing is because we have a y squared over here, which means that it has an additional x plus 5. What we're going to multiply top and bottom by here is this x plus 1. X plus 1 and x plus 1 needs to be multiplied. So what we'll do now is have our common denominator of x plus 5, quantity squared, times the x plus 1, our common denominator, times, or divided into, 5 times x plus 5 minus 2 times x plus 1. Multiply this out, we'll end up with 5x plus 25 minus 2x minus 2, divided by the common denominator, x plus 5, quantity squared, times x plus 1. The last thing we'll do here is we'll collect all of our like terms in our numerator and write that out. So we'll end up with 3x, the 5 minus the 2, plus 23, when we have 25 minus the 2, divided by x plus 5, quantity squared, times x plus 1. With the last 3 problems, what we have here is we have equations that we need to solve for the x value. In each one of these equations, what we want to do is eliminate the denominator. In the first problem, number 3, we'll want to factor this x squared minus 4 into x minus 2, x plus 2. We look through this all the denominators for this problem, and we see that we have x minus 2 and x plus 2 in each one of the denominators. So what we'll do is we'll take and multiply everything by x minus 2, x plus 2, so they'll cancel. So we'll multiply here with x minus 2, x plus 2. We'll multiply here with x minus 2, x plus 2. And we'll multiply here with x minus 2 and x plus 2. In this first term, the x plus 2 and the x plus 2 will cancel out, and then it will leave us just with x minus 2. In the second term, x minus 2 over x plus 2, they will both cancel out with the denominator, so we'll be left with just plus 4. In the last term, there is no denominator, so we'll just be left with x minus 2, x plus 2. And from this point, it's very easy to solve this problem. We basically have a linear problem that will just collect all our like terms on one side and then solve. Over here, we'll first multiply x squared minus 4, and we'll collect our like terms over here is x and plus 2. Now we'll move these terms over to here, setting this equal to 0. We'll have x squared minus x minus 6. And since this is a quadratic where we have x squared, what we'll need to do is we'll need to factor this out. This will then factor into x minus 3, x plus 2, and we'll end up with solutions of x is equal to 3 and x is equal to negative 2. And problem number 4, what we'll need to do is again find that common denominator and multiply everything, each one of the terms by that. In this case, what we have is 6x. The 2x and the 3 will give us 6x, and so we'll have to multiply everything by 6x. 3 goes into 6 twice, so this will leave us with 2x times 5. The 2x goes into 6x and leaves me with 3, so we'll end up with a minus 3 times 3. And over here, we'll end up with the 2 going into 6 3 times, and so we'll end up with 3x times 3. Now this problem's a little bit simpler because you can see we don't have any x squared terms in it. And so we'll end up with just 10x minus 9 is equal to 9x. Getting everything to one side, we'll bring the 10x over. Minus 9 is equal to minus 1x, and so x is equal to 9. In problem number 5, this is a much more simpler problem because this is actually set up that I have a ratio is equal to another ratio, and so what I can do is do cross multiplication with this problem. I can take 3 times x plus 1 and cross multiply the 5 and the x plus 2, and 5 times x plus 2 is what you have over here. So we end up with 3x plus 3 is equal to 5x plus 10. Now all we'll have to do is get all the x's on one side and all the constants onto another side. Subtracting 3x, we'll end up with 2x. Subtracting the 10, we'll end up with minus 7. So the answer for this one is minus 7 halves.